Now we take another example. Find the equation of the line which is at right angles to 3x plus 4y is equal to 12 such that its perpendicular distance from the origin is equal to the length of the perpendicular from 3, 2 on the given line. The solution. Given line is 3x plus 4y minus 12 is equal to 0, equation I. Let any line perpendicular to given line is 4x minus 3y plus k is equal to 0, equation II. By given its perpendicular distance from the origin is equal to the length of the perpendicular from 3, 2 on the given line. So length of perpendicular from origin, that is 0, 0 on II is plus minus 4 into 0 minus 3 into 0 plus k divided by root over 4 square plus minus 3 square. This is plus minus k upon 5. Now length of perpendicular from 3, 2 on equation I is plus minus 3 into 3 minus plus 4 into 2 minus 12 divided by root over 3 square plus 4 square. This is plus minus 3 into 3 9 plus 8 minus 12, which is 9 plus 8 17 minus 12, 5 upon 5. This is just 1. By the question, plus minus k upon 5 is equal to 1. Therefore, k is equal to plus minus 5. Now, substituting the value of k in equation II, we have the second equation 4x minus 3y plus k, and k is plus minus 5. Plus minus 5 is equal to 0, which is the required equation. Okay, we take another example. Find the equations of two straight lines drawn through the point 0, a on which the perpendicular distance from the point 2a, 2a are each of length a. So solution is, here we have to find the straight line which passes through 0, a. That is 0, a, which is a straight line. Now the perpendicular distance from 2a, 2a. 2a, 2a. This is the point. The length of perpendicular from this point on line is a. Then equation of a straight line, that is equation of AB, what? Let any line passes through zero, a is y minus y1, which is a, is equal to m times x minus x1, this is 0, or mx minus y plus a is equal to 0, equation I. That is, equation of AB is mx minus y plus a is equal to 0. Since length of perpendicular from 2a comma 2a on I is a. Therefore, a is equal to plus minus a is m into x1. x1 is 2a. 2a minus 1 into y1. y1 is again 2a plus a, divide by root over a square. We have a is m is square plus b square. b is minus 1 whole square. Continue. This is a is equal to plus minus 2am minus a, divide by root over m square plus 1, or a times root over m square plus 1 is equal to plus minus a is common, am 2m minus 1. Here a cancel. Squaring on both sides, we get m square plus 1 is equal to 4m square minus 4m plus 1. 1 again cancel, or 4m square minus m square, 3m square minus 4m is equal to 0, or m common, 3m minus 4 is equal to 0. Therefore, m is equal to 0 comma 4 upon 3. When m is 0, required line is from equation I, mx, m is 0, mx 0 into x minus y plus a is equal to 0, or y is equal to a. Similarly, when m is 4 by 3, now equation I becomes, required line is mx 4 by 3 x minus y plus a is equal to 0, or this is 4x minus 3y plus 3a is equal to 0. Therefore, y is equal to a, and 4x minus 3y plus 3a is equal to 0 in the required lines. We take another example. So that the product of the perpendiculars drawn from the 2 points plus minus is root over a square minus b square comma 0 on the line x by a cos theta plus y by b sin theta is equal to 1 is b square. So solution, here length of the perpendicular from root over a square minus b square comma 0. Plus minus ma actually plus ko matra liएको, taking positive sign, we get root over a square minus b square comma 0 on the line x by a cos theta plus y by b sin theta minus 1 is equal to 0 is b P1, and P1 is equal to plus minus AX1. We have A is coefficient of X, cos theta upon A. Cos theta upon A. A X1, we have X1 is root over A square minus B square, plus B is coefficient of Y, sin theta upon B, sin theta upon B into Y1. Y1 is 0. Plus C, and here C is minus 1. Minus 1 upon root over A square plus B square. A is cos theta upon A whole square, plus B is sin theta upon B whole square. This is plus minus cos theta into root over A square minus B square upon A, this is 0, minus 1 whole upon root over cos square theta upon A square plus sin square theta upon B square. And this is cos theta plus minus cos theta into root over A square minus B square minus A upon A into 1 upon B square cos square theta root over B square cos square theta plus A square sin square theta whole upon root over A square B square. The root बाट बाहिर आयो AB, त्यसलाई माथि लेखेँ AB. A cancel. This is plus minus B into A B cos theta root over A square minus B square minus AB, A into B upon root over A square sin square theta plus B square cos square theta. This is plus minus 1 is common, then this is AB minus B times root over A square minus B square cos theta minus commonly अगाडि प्लस माइनस बेसी फेरि प्लस माइनस सँग माइनस लगाउँदा प्लस माइनस ए अपन रूट ओभर A square sin square theta B square cos square theta. Similarly, the length of perpendicular from the point minus root over A square minus B square comma 0 on given line is P2, which is equal to plus minus AX1. X1 is negative root over A square minus B square plus BY1. Y1 is 0 plus C. C is minus 1 upon root over A square plus B square. And it becomes plus minus negative root over A square minus B square cos theta upon A. This is 0, just minus 1 upon root over cos square theta upon A square plus sin square theta upon B square. And here minus is common, then it again plus minus root over A square minus B square cos theta A into 1 A upon A into here B square cos square theta plus A square sin square theta whole upon root over A square B square, which is AB. A cancel. It becomes plus minus B into A, AB plus B into root over A square minus B square cos theta into B upon root over A square sin square theta plus B square cos square theta. Now P1 into P2 plus minus AB minus B times root over A square minus B square cos theta into AB plus B times root over A square minus B square into cos theta. Here A minus B, A plus B. So this is, here B is common, first B is common, then plus minus B and A minus root over A square minus B square into cos theta. Similarly, here again B is common, A plus root over A square minus B square cos theta, divide by this into this, which is just A square sin square theta plus B square cos square theta. This is plus minus B into B, B square, and A minus B, A plus B, which is A square minus B square. A square minus A square minus B square cos square theta, cos square theta, upon A square sin square theta plus B square cos square theta. And this is plus minus B square, A square minus A square cos square theta minus minus plus B square cos square theta upon A square sin square theta plus B square cos square theta. And this is plus minus B square, here A square common, A square, then 1 minus cos square theta sin square theta plus B square cos square theta upon A square sin square theta plus B square cos square theta. This cancel, and this is plus minus B square, but product of two distance is always positive, so this is just B square, hence proved. We take another example. The origin is a corner of a square and two of its sides are y plus 2x is equal to 0 and y plus 2x is equal to 3. Clearly y plus 2x is equal to 0 and y plus 2x is equal to 3 are parallel. Find the equation of the other sides. This is x-axis, y-axis, origin. Here the origin is a corner of a square. OABC is a square. Clearly y plus 2x is equal to 0 satisfies 0, 0. So y plus 2x ले 0, 0 satisfy गर्छ. त्यसको मतलब OA र OC मा कुनै एउटा इक्वेसन हुनु पर्यो. तपाईलाई OA मा राख्दैछु. 2x plus y is equal to 0. Similarly, y plus 2x is equal to 3 is parallel to 2x plus y is equal to 0. So, equation of BC is 2x plus y is equal to 3. यदि हामीले 2x plus y is equal to 0 लाई OC राखेको थियो भने यो इक्वेसन लाई AB मा राख्नुपर्छ. Now, we need to find equation of OC and AB. Let OABC be a square with sides with equations of sides OA and BC are 2x plus y is equal to 0 and 2x plus y is equal to 3 respectively. since OC is perpendicular to OA, similarly C90, B90, A90. Since OC perpendicular to OA and OC passes through the point the origin, that is 0, 0. OC OA सँग perpendicular छ र origin बाट पास भएको छ. Therefore, equation of OC is just x minus 2i. X minus 2i is equal to 0. Since AB is parallel to OC. Since AB is parallel to OC. So let equation of AB be x minus 2i plus k is equal to 0. Equation I. Since OABC be a square, so OA is equal to AB is equal to BC is equal to OC. All sides are equal. OA is equal to length of perpendicular distance from O 0, 0 on equation I, which is AB. This is plus minus AX1. Here A, coefficient of X is 1, X1 is 0, plus B is minus 2 into Y1 is again 0, plus K divided by root over 1 square plus minus 2 square, and this is plus minus K divided by root 5. Similarly, OC is equal to length of perpendicular distance from O, that is 0, 0 on equation BC. BC is 2x plus y minus 3 is equal to 0. And this is plus minus 2 into 0 plus 1 into 0 plus c is minus 3 divided by root over 2 square plus 1 square, and this is plus minus 0 plus 0 minus 3. Here plus minus, so this is 3 upon root 5. But OC is distance, so this is just 3 upon root 5. Since OC is equal to OA, we have OC is 3 upon root 5, and OA is plus minus k upon root 5. Therefore, root 5 cancel, k is equal to plus minus 3. Now, substituting the value of k in equation 1, we get x minus 2i plus k, and k is plus minus 3 is equal to 0. Therefore, required equations of other sides are x minus 2i is equal to 0 and x minus 2i plus minus 3 is equal to 0. Okay students, we have one important theorem equation of the bisectors of the angle between two lines, which is very important for us. Suppose this is x-axis and y-axis, which is origin. Here AB, one line, and CD, another line. Angle bisectors. Let AB and CD be two straight lines whose equations are a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Let p h comma k be any point one of the bisectors of the angle between two lines AB and CD. तो PH कमा के यो बाइसेक्टर र यो बाइसेक्टर मध्येमा कुनै एउटाको पोइन्ट PH कमा के मैले सपोज गर्छु। यहाँ लिए PH कमा के from P draw perpendicular PQ and PR. Then by geometry, P is the equidistance from the two lines AB and CD. Drawn PQ perpendicular to CD and PR perpendicular to AB. Now PR is equal to let the perpendicular from PH comma K on the line AB, which is plus minus A1H plus B1K plus C1 root over A1 square plus B1 square. Similarly, PQ is equal to plus minus the length of perpendicular from PH comma K on the line CD, which is A2H plus B2K plus C2 divided by root over A2 square plus B2 square. What we have? PR is equal to PQ, or the PR plus minus A2H plus B2K plus C2 upon root over A2 square plus B2 square is equal to plus minus A1H plus B1K plus C1 upon root over A1 square plus B1 square. That is A1H plus B1K plus C1 upon root over A1 square plus B1 square is equal to plus minus A2H plus B2K plus C2 upon root over A2 square plus B2 square. Since these relations are true for every point P, H, K. So the equations of the bisectors of the lines AB and CD are A1x plus B1y plus C1 upon root over A1 square plus B1 square is equal to plus minus A2x plus B2y plus C2 upon root over A2 square plus B2 square, A2 square plus B2 square. If we take positive sign, then we get one bisector. Similarly, if we take negative sign, then we get another bisector. This like B1, bisector B1 and B2. Okay, we have two important notes. One is to identify the bisector of the angle containing the origin. दुईटा bisector मध्येमा कुन bisectorले originलाई contain गर्छ? First of all, let the two lines be written so that C1 is positive and C2 is again positive. Given line को constant termलाई positive बनाउने. Each point on the bisector of the angle containing the origin must make the equation both positive. Each point on the bisector of the angle containing the origin must make the equation both positive. Therefore, the bisector of the angle in which the origin lies is taking positive sign. Similarly, the equation of the bisector of angle not containing origin is taking negative sign. तो सबसे पहिला C1 र C2 given equation को constant termहरूलाई positive बनाउनु पर्छ. तब बल्ल origin contain गर्ने र origin contain नगर्ने bisector को आइडिया हुन्छ. अब धेरै स्टुडेन्टलाई यहाँ origin contain गर्ने origin बाट पास भएर जाने हो कि नचाहिँदो कुराहरु चाहिँ नि उले बुझ्न सक्छ. सो क्लियर हौ. origin contain भनेको के हो? Suppose we have two lines. We have two lines like this L1 and L2. The bisector B1, bisector B2. The B1, B2 कुनले ओरिजिनलाई कन्टेन गर्छ भन्दा यदि हामी B1 को एंगलमा सेट गर्दै आउने भने ओरिजिनमा पनि सेट गर्ने भयो. सो B1 contain the origin. यतापट्टि B2 मा म बनाउँदै जान्छु भने अथवा यतापट्टि ओरिजिनमा सेट हुने भएन. सो B2 ले ओरिजिनलाई कन्टेन गर्दैन. ओके, another notes II to identify the acute or obtuse angle bisectors. Take any one of the given lines, either L1 or L2, and any one of the bisectors B1 or B2 such that theta be the angle between them, that is one bisector and one given line. Theta be the angle between one bisector and one given line. And if tan theta, modulus of tan theta is less than 1, then bisector is acute angle bisector. Similarly, if modulus of tan theta is greater than 1, then bisector is obtuse angle bisector. Now take one very important example. Find the equation of the bisectors of the angles between two lines 4x minus 3y plus 1 is equal to 0 and 12x minus 5y plus 7 is equal to 0. And prove that the bisectors are at right angles to each other, that is perpendicular to each other. Also identify the bisector of the angle between the lines containing the origin. Solution: the bisectors of the angle between of the angles between two lines 4x minus 3y plus 1 is equal to 0 and 12x minus 5y plus 7 is equal to 0 are given by a1x plus b1y plus c 1 upon root over a1 square plus b1 square is equal to plus minus a2x plus b2y plus c2 upon root over a2 square plus b2 square, or we have a1x plus b1y plus c1 which is 4x minus 3y plus 1. 4x minus 3y plus 1 divided by root over 4 square plus minus 3 square is equal to plus minus a2x plus b2y plus c2 which is this 12x minus 5y plus c2 7 divided by root over 12 square plus minus 5 square. Now continue. 4x minus 3y plus 1 upon root over 25 plus is equal to plus minus 12x minus 5y plus 7 upon root over 169. तो क्वेसन बनाउँदै जाँदा बाइसेक्टर मात्र निकाल्नु थियो, कन्टिन्यू हामी फटाफट बनाउन सक्छौं, तर मलाई यस्तो बाइसेक्टर जसले ओरिजिन कन्टेन गर्छ त्यो पनि निकाल्नु छ। त्यसको लागि सुरुमै हामीले एउटा कुरा ख्याल राख्नु पर्थ्यो, कन्स्ट्यान्ट टर्म c1 र c2 पोजिटिभ बनाएर राख्नुपर्छ। इन केस यो नेगेटिभ थियो भने मैले माइनसले मल्टिप्लाई गरेर पोजिटिभ बनाउँथे, तर अलरेडी यो दुईटै पोजिटिभ छ। सो कन्टिन्यू। दिस इज 4x minus 3y plus 1 root over 169 which is 13. 13 times 4x minus 3y plus 1 is equal to root over 25 is 5. This is plus minus 5 times 12x minus 5y plus 7. Taking positive sign, we get 52x minus 39y plus 13 is equal to 60x minus 25y plus 35, or 60x minus 52x 8x minus 25y plus 39y plus 14y 35 minus 13 plus 22 is equal to 0, or here 2 is common, then 4x plus 7y plus 11 is equal to 0. Slope of 4x plus 7y plus 11 is equal to 0 is minus coefficient of x 4 divided by coefficient of y which is 7. This is M1C. Similarly, taking negative sign, we get 52x minus 39y plus 13 is equal to minus 60x plus 25y minus 35. The 52x plus 60x, or this is 112x minus 39y minus 25y, which is 64y plus 13 plus 35, which is 48, is equal to 0. Or here 16 is common, and this is 16 times 7x minus 4y plus 3 is equal to 0, or 7x minus 4y plus 3 is equal to 0. The slope of 7x minus 4y plus 3 is equal to 0 is again minus coefficient of x, which is 7, upon coefficient of y, which is minus 4. This is just 7 upon 4 is equal to m2 c. Therefore, required bisectors are 4x plus 7y plus 11 is equal to 0 and 7x minus 4y plus 3 is equal to 0. Also, m1 into m2, we have m1 minus 4 by 7 into m2. m2 is 7 by 4. 4 4 cancel, 7 7 cancel, which is minus 1. Therefore, two bisectors are perpendicular to each other. Last one, to identify the bisectors containing the origin. The first bisector, this one, taking positive sign, we get 4x plus 7y plus 11 is equal to 0. दुईटा बाइसेक्टर निकाल्दाखेरि हामीले टेकिङ पोजिटिभ साइन गरेका छौं, त्यति बेला यो बाइसेक्टर आको. Therefore, the bisectors 4x plus 7y plus 11 is equal to 0 is the bisectors containing the origin. यो कुरामा फेरि एकचोटि क्लियर गरौँ. बाइसेक्टर निकाल्ने क्रममा टेकिङ पोजिटिभ साइन गर्दाखेरि निक्लेको बाइसेक्टर 4x plus 7y plus 11 is equal to 0 is the bisector containing the origin. We have another example. Find the equations of the bisectors of the angles between the lines y is equal to x and y is equal to 7x plus 4. Identify the bisector of the acute angle. Solution. Given lines are x minus y is equal to 0 and 7x minus y plus 4 is equal to 0. The equation of the bisectors of the angles between given lines are x minus y upon root over 1 square plus minus 1 square. a1x plus b1y plus c upon root over a1 square plus b1 square is equal to plus minus 7x minus y plus 4 divided by root over 7 square plus minus 1 square or this is x minus y upon root 2 and this is plus minus 7x minus y plus 4 divided by root over 7 square plus minus 1 square, which is root 50, 25 into 2, so this is 5 upon root 2. Root 2 cancel. Or 5x minus 5y is equal to plus minus 7x minus y plus 4. Now taking positive sign, we get 5x minus 5y is equal to 7x minus y plus 4. Similarly, taking negative sign, we get 5x minus 5y is equal to minus 7x plus y minus 4. Or 5x, 7x minus 5x, 2x minus y plus 5y plus 4y plus 4 is equal to 0. Here, dividing both sides by 2, we have x plus 2y plus 2 is equal to 0. Or 5x plus 7x, which is 12x, minus 5y minus y minus 6y plus 4 is equal to 0. Here again, dividing both sides by 2, we get 6x minus 3y plus 2 is equal to 0. Therefore, required bisectors are x plus 2y plus 2 is equal to 0 and 6x minus 3y plus 2 is equal to 0. For acute angle bisector, we take any one of the given lines. Now we take first line. The slope of first line, that is x minus y is equal to 0 is m1, which is 1. Slope of x minus y is equal to 0 is m1, which is 1. Similarly, we take any one of the above bisectors, either x plus 2y plus 2 is equal to 0 or 6x minus 3y plus 2 is equal to 0. अहिले हामी यसलाई लियौं. The slope of x plus 2y plus 2 is equal to 0 is m2, the minus coefficient of x upon coefficient of y, 2. If theta be the angle between the first line, given line, and first bisector, if theta be the angle between the first line and first bisector, then tan theta is m1 minus m2 upon 1 plus m1 into m2. This is, we have m1 is 1 minus m2 is minus 1 upon 2. So this is plus 1 upon 2. 1 plus 1 into minus 1 upon 2. This is 3 by 2 upon 1 by 2. 2 to cancel. This is just 3. Since modulus of tan theta is 3, which is greater than 1. So, first bisector. So, the bisector, first bisector, that is x plus 2y plus 2 is equal to 0 is the obtuse angle bisector. Therefore, the bisector, second bisector, that is 6x minus 3y plus 2 is equal to 0 is the acute angle bisectors.